Hi, and welcome to day 12 of polynomials. Today we are talking about mastering factoring. So we're working with factoring again. For each of the following expressions, what similarities do you notice between the examples in the left column and those on the right? Well, for A, we have x squared minus 1, which is the difference of two perfect squares. So we have x plus 1, x minus 1, and that's what we call a good twin, bad twin. For B, it's the same type of problem, except that now I have a 9 in front of the x squared, but otherwise everything works the same. So it's 3x plus 1, 3x minus 1. Okay, good twin, bad twin. For letter C, it's just a polynomial. Factors of 15 that add up to 8 are 3 and 5. And since the last side's positive, the signs are the same. Take the sign in the middle, so it's plus and plus. D is kind of similar. We have a 15 on the end, and we have an 8 and 16. They're related to each other, but let's just do this by grouping. So 4 times 15 is 60. My factors of 60 that add up to 16 would be positive, so it'll be 1 and 60, 2 and 30, 3 and 20, 4 and 15, and then 6 and 10. And the pair that adds up to 16 is 6 and 10. So we will have 4x squared plus 6x plus 10x plus 15. Group. Here we have a 2x in common, and I'm left with 2x plus 3. Here we have a 5 in common, and I'm left with 2x plus 3. Now they have a 2x plus 3 in common, and I'm left with a 2x plus 5. For letter E, it's the difference of two perfect squares. So it's x plus y, x minus y. F is essentially the same problem, except I would have x squared plus y squared and x squared minus y squared. The difference here is this one is not factorable because it has a plus sign in it. This one right here, because it's a minus sign, I have the difference of two perfect squares again. So bring down my factor that's not factorable, and I'm left with x plus y, x minus y. Notice the difference between what we were doing before, in the days before, and then today is today we don't have it equal to 0, so we're not actually solving anything, and we can't throw an equal 0 in and get answers. I just want it factored. I don't want solutions. There's a difference between finding a solution and finding a factor. So write 9 minus 16x to the fourth as the product of two factors. Well, this is a difference of two perfect squares, and the square root of 9 is 3. And 16x to the fourth is 4x squared. And good twin, bad twin. Notice usually we have our x out in front, but since the x was in the back, we keep it in the back when we factor. And this is not factorable again because 3 is not a perfect square. So example 2. For example 2, what we're looking for is a GCF first, because that's really kind of crazy. So the greatest common factor, they both have an x squared in common. So we'll put the x squared out in front. Then I'm left with 4y to the fourth minus 25x squared z to the sixth. And that is really the difference of two perfect squares, albeit a crazy one, but everything, all the powers are even, so that makes their perfect squares. 4 and 25 are perfect squares, and the minus sign. So leave the x squared, and I'm going to factor, and the square root of 4y to the fourth is 2y squared, and then plus the square root of 25 is 5, so x squared is x, and z to the sixth is z to the third. And then we have the same thing, 2y squared and then minus 5x z to the third. All right, the next one. Factor the following expressions. There is no GCF here, so this one we're going to have to do a little multiplying. 4 times negative 63 is negative 252. Now 252 is a large number, so I took the liberty of looking up the factors that I needed on the calculator. I did 252 divided by x, and then I looked for my pair that subtracted to give me 4. And since I was looking for such a small difference, I needed to find two numbers close to each other. And the factors that I got were positive 18 and negative 14. So when I rewrite this, I have 4x squared plus 18x minus 14x minus 63. So group and group, and I do that, I will have a 2x in common. So I'm left with 2x plus 9. And over here, I have a negative 7 common. So then I'm left with 2x plus 9. So I have a 2x plus 9 in common now. And I'm left with 2x minus 7, my factor. So it really wasn't so bad. Letter B is a little bit different in that 12, 24, and 15 all have a factor of 3. So if I factor out that 3, I'm left with 4y squared minus 8y minus 5. And that's a little bit easier to work with than trying to do the 12 times the 15 and do your common factors that way for factor by grouping. So 4 times negative 5 is negative 20, and I need them to add up to negative 8. So negative 10 and a positive 2 is what I'm looking for. So I will have 3, and then I will have 4y squared minus 10y plus 2y minus 5. So I will have 3, and then I'm going to group and group. And in the first group, they have a 2y in common, and I'm left with 2y minus 5. In the second group, there's nothing in common, so I'm just going to put a plus 1 out in front, and a 2y minus 5. So now they each have a 2y minus 5, and what's left over from that is 2y plus 1. For number 2 through 4, we're going to factor each of the following and show that the factor form is equivalent to the original expression. What we need to do is look over here in the lesson summary, and the sums and differences of cubes can be factored by using these formulas. It's not something you had to memorize. Remember I told you you could do log division or synthetic division to help you out. But what we're looking for is when we have cubed, you want to look for the cube root here and the cube root here. If you have a positive, then it's a positive cube root. If you have a negative, then it's a negative cube root. And then everything else will follow using this formula. So for the first one, a cubed plus 27, the cube root of 27 is 3. So I will have a plus 3 as my first factor. And then following the formula on the next page, this becomes a squared minus 3a and then plus 9. And these come from the patterns that we looked at on day 6 for a reference. And this looks like a 9. That's an A, really. I promise it's an A. So the next one, number 3, I have x cubed minus 64. Well, the cube root of negative 64 is negative 4, so it's x minus 4. And then I have x squared plus 4x plus 16, again coming from the other page, and just following my patterns. Here, for 2x cubed plus 128, 2 is not a perfect cube, nor is 128, but they have a GCF of 2, or creates a common factor of 2. So I'm left with x cubed plus 64. Well, we just did 64 up above, so leave our 2. We'll have x plus the 64 this time, which will be with x squared minus 4x and plus 16. And that's really all of the mastering factoring that we have for this unit. We will continue to work with factoring in the next unit and the unit following. So factoring is pretty huge. So if you're struggling with the factoring, please come in and let me know.